All right, everyone, we're going to go ahead and get started. We've got a lot of information to cover here real quick, so we'll get started. Hello, everyone. My name is Randy Plumlee. I'm the Energy Program Manager for SPEER. Thanks again for joining us. I'll go over a little bit of housekeeping first. Shortly after today's webinar, you'll receive a course evaluation form from Kathy Lawrence. If you're wanting IECC CEUs, please make sure you complete the evaluation form and submit it. After submitting it, you'll receive a course evaluation completion certificate in another email from Kathy that contains the course ID that you'll need to use when reporting CEUs to IECC. Also, this webinar is being recorded. It will make its way to SPEER's YouTube channel. You can find that link on our website under a resources page. There's also other videos there in relations to energy, HVAC, and others, as well as policy and legislation as it relates to energy efficiency. So lastly, the chat option is open, but we'll be holding all questions to the end of the presentation. So if you have any questions, please put them in the chat and I'll review them at the end. So in case those of you who are not familiar with SPEER, we're a nonprofit organization whose mission is to advocate the acceleration and adoption of the latest energy efficiency codes, including energy efficient products and services that are offered throughout Texas and Oklahoma. My job is to educate, teach, or train all things related to IECC and IRC, including the residential and commercial, and also including the ASHRAE 90.1. We offer online and in-person trainings, as well as on-site field trainings for inspectors, contractors, and trades. We have funding that allows me to travel anywhere through Texas and Oklahoma. This funding is also included with having me give out IECC books and can hand those out in person or on-site field trainings. So if your organization or jurisdiction would like to schedule something with me or another team member at SPEER, please email me and we can get that scheduled. So next I have 3 quick poll questions I'd like to ask. These will only take a couple of minutes. I'll give about 30 seconds for each, and your feedback is greatly appreciated. So you should see the first one there. It says, who are you representing? Basically, are you a third-party energy inspector, a city inspector, plan reviewer? I think there's some that are duplicated there. If you just take a moment just to answer those, I'd appreciate it. Also, there's other questions. I guess it's asking them all at one time. Sorry about that. It says, are you IECC certified, yes or no? What climate zone is your jurisdiction in? And which code cycle is your jurisdiction currently under? So that'll help me in the future focus on my training and get that to the right audience. So we'll give that about a few more seconds, and then we'll close the polling. About half the room has participated. Again, that participation actually helps me focus my training in the future for webinars and in-person trainings. All right, we'll wait about 30 more seconds. It looks like a little over half has participated. All right, great. I'll leave that up for just a few more seconds and we'll start on with the presentation. Thanks again for your feedback. That really is appreciated and very helpful. So a little bit about me. I know I've talked about this before in the past, but I've worked as an energy auditor, an inspector, and managed one of the North Texas largest third-party energy verifiers, where I trained the energy inspectors for the field team. So I have over 10 years experience in energy-related inspections for existing and new single-family and multifamily construction, as well as energy audits on existing houses. So, all right, I'll go ahead and close the poll. I appreciate it again for your feedback on that. Thank you very much. All right. As most of the inspectors that I've trained can attest to, once you're certified and you have a certification that says I know a little something about energy, you want to follow the book word for word and ensure that every house is 100% complete with everything. And then reality kicks in and you realize that construction is messy and it's far from perfect, and not every house will hit 100%. I quickly had to learn that having the title Captain Red Tag was not a good thing. And when the client is paying for you and for your inspection services, sometimes that means they have to make compromises. So we'll get on with this a little bit, but a little small couple of slides about the code book, how it's proposed, how it's developed, and how it's actually done by IECC. So historically, the IECC is a conglomeration of other standards and codes that were throughout different parts of the country. Slowly, these morphed and merged and became what we know today. Improvements have been made with each code cycle, some more than others. So if you've been in the industry as long as I have, you definitely remember the big jump in efficiency between 2009 and 2012. That was approximately 12 to 15%. Then there was very little change between 2015 and 2018. They used that time to do some cleanup. But then there'll be another significant jump coming in 2021 IECC. It'll be about a 9% improvement from that for energy efficiency. So the IECC updated its framework on how the IECC is proposed and developed. The 2018 IECC will be the last code cycle that will be considered a code and not a standard. That changed with the 2021 when the IECC adopted the ANSI standards process. This change will allow for more time to be considered for proposed changes that come from open public comments. However, with more time being given, it's still a little bit more difficult to get a proposal changed due to the fact that the new process consists of a smaller committee, and the proposal must receive a majority vote from the committee before it continues on the approval process. So the climate zone map you see here, we've been using largely unchanged for several code cycles, but then the IECC decided to move to more of an accurate, in my opinion, more accurate climate zone map from ASHRAE. The 2021 IECC will be the first to use this ASHRAE map, and several counties in Texas will see a climate change into different climate zones. This brings some confusion to some builders that build in different counties and that may now be building the same house but in different climate zones. Most volume builders will usually choose to build all houses to meet the newest version to lessen confusion amongst their contractors and suppliers, and that's not a bad thing to do. I'm in Dallas County, more specifically in the city of Rowlett, which is split between Dallas and Rockwall County. With this change, Dallas moved to 2A, Rockwall stays to 3A. The city has chosen to consider all homes being built in their city in Zone 2A. So I have a little bit of mixed feelings about that due to the fact that 3A is a little more energy efficient. 2A actually allows for a higher ACH, it means the house is built less tight. But there were other considerations to be made and it would also mean an increase in building costs to the builders. So I do understand their decision in that. With the 2015-2018 IECC, only 2 inspections are really required. It's the framing and rough-in inspection. And I say 2 inspections, there's a list of 5 inspections, but it comes down to 2 on-site inspections. The framing inspection and rough, also known as the pre-drywall inspection, and a final inspection. During the pre-drywall inspection, plumbing and mechanical rough-in inspection should also be performed. With the 2021, a pre-insulation, also known as the polysil inspection, will be required. So hopefully most of your builders in your area are already getting a 3rd inspection, calling it an air seal inspection, an air barrier inspection. A lot of times in Dallas, we just call it a polysil inspection. So this is vital to basically confirming all penetrations to the unconditioned space and to the outside has been properly sealed. Not only does this ensure a lower blower door score, but it also, and more importantly, It lessens the occurrence of moisture into the building envelope. Lastly, it keeps air movement out of the wall insulation and allows for the effective R value to be more closely maintained to the installed R value. So if more air is allowed to move through insulation, it lowers the overall effective R value. For example, if a wall is R13 and the cavity insulation is leaky, it'll have basically an overall effective R value closer to 9 or 10. We'll see that more in specifics later. Sadly, a large portion of builders are only concerned with just passing the blower door and do not fully understand the impact of allowing their houses to only meet the minimum. So as they say, a house built to just meeting minimum is the worst house that can be built and still be code compliant. Also, with much of the building being built in rural areas, many of these houses are being built in non-jurisdictional areas and are not being held to any recent updated versions of the IECC. So the first one, or the second that we'll see, this is what we're talking about with the polysill inspection. Sorry, as the photos kind of speak for themselves, but all penetrations into the unconditioned space must be sealed. These are the easy ones to find in these pictures, but with ceiling height changes, window bump outs, and architectural designs that we're seeing today, these things can get complicated really fast. So most common air sealing material in construction today is what they call self-expanding polyurethane foam, also known as polyseal or just poly. But I always ask the question, does that meet the intent of the code? So R402.4.1 states that sealing methods between dissimilar materials shall allow for a differential expansion and contraction. So is that something that polyseal does? So after looking up and looking at some of different manufacturers' websites on their product specifications, none of them actually meet this requirement, but are still allowed to be used. Yes, they're fire rated. Yes, they stop air, but only for a snapshot of time. So after the house experiences both heating and cooling, many products have expanded, contracted at different rates, and the sealing material is no longer as it was when it was constructed. We all know that wood shrinks over time. The spaces in between get further apart. And now add that to material expansion of different material and contraction, then there's no wonder why basically a house has a higher blower door score if tested again a year from after being completed. So after the polysill inspection hopefully has been performed, then the second most important job for the inspector is to verify that all insulation meets the manufacturer's instructions of installation, also known as grade 1. So things need to be verified, such as voids, gaps, compressions. The higher percentage of these results in a lower effective R value. As you can see on the chart to the right, the R13 wall that we see on the left, if it had only 4% gaps, it'll perform at an R9 level. So this wall here has no holes in it, but now punch holes in those walls and call them windows and doors, and the overall weighted average of that wall will be more like a 5 or a 6, or depending on the square footage of the wall compared to square footage of the openings. This is kind of like the domino effect. Do a poor job of sealing the holes in the air barrier, a poor job of installing the insulation, add windows and doors, and you might as well not insulate. Not really, that's not true. But the more heat transfer that happens, the more likely the movement of condensation point within the wall will happen. If heat from the outside is allowed to move faster through the wall because of poorly installed insulation and holes in the air barrier, the closer it can get to the colder conditioned inside air and possibly reaching the cold surface of the sheetrock. So the place where hot meets cold can become a point of condensation, and with that, bad things can happen inside the wall or even on the interior surfaces. So once the occupants see it on the interior surfaces, it becomes a warranty call and possible long-term litigation. So calling for blower door and duct blaster is sometimes what builders will do, but having those brought back out after a bit of time when the home's been sitting and going through conditioning phases most of the time those results are inconclusive. The blower door comes in at under target, the duct blaster comes in under target. So it's not normally due to an air leakage thing. It's mostly due to voids, gaps, and compressions within the insulation. So the home is still airtight. The ducts are still airtight, but heat transfer is allowed to happen so much faster due to compressions or voids and not obtaining that grade 1 insulation. So knee walls are a big thing, especially with all the ceiling height changes that we see around here. Exterior walls see a temperature difference, varying degrees from highs to lows, but no part in the country sees highs in the 130s, 140s, up to 160 plus, but knee walls do. So these are widely overlooked and sometimes only considered an interior wall that just happens to separate conditioned from unconditioned spaces. However, these spaces and specific areas are subject to the highest temperature differentials of any component within the building thermal envelope and should be specifically addressed and verified that all insulation is within a 6-sided encapsulation, means top, bottom, side to side, front to back, and will be completely airtight and the correct R value installed, and that it also achieves the installation grading of 1. So anything less than that greatly increases the heat load allowed to enter into the conditioned space by just heat transfer. Most of the time, those interior knee walls are high enough and above the head height of an occupant, so it doesn't normally turn into a source of complaint about comfort. But the load calculations and the sizing of the HVAC has been designed in the consideration that these areas have been done properly with insulation and air sealing, have obtained a grade 1, and not having these details done correctly will lead to the HVAC unit not being able to meet the load and the occupants no longer being comfortable. This in turn leads to occupant turning down the AC, which increases the energy used to maintain comfort. So the higher the ceiling, the more it pockets at the top, the more that it starts pillowing down and starts reaching the conditioned space where the homeowner or occupant can feel it. Then they start adjusting the thermostats. So keeping those knee walls to a grade 1 and airtight is absolutely essential. So several items must be verified and collected at the final inspection, from a blower door to light count to collecting appliance model numbers, including water heater and HVAC model numbers. So running the blower door is kind of like grading how well the house was built. How tight were they able to get it? But keep in mind, all the inspections are just a snapshot in time. So anything can and does happen once the inspector walks out. So every contractor, especially electricians and plumbers, from my experience, always have foot saws with them and can easily kick holes in a well-done air barrier. So if this is done after the pre-drywall inspection and it's been sheetrocked, it may never be noticed until the blower door. So a popular myth around blower doors is that the blower doors can pinpoint and find areas of leakage. This is far from the truth, and blower doors only estimate leakage at a known pressure. It's a test that needs to be done specifically with specific parameters so that everything's equal across the industry. So this leakage can happen anywhere, including inside the exterior walls, ceiling penetration, subfloor connections, connections to ports and patios. Most of these can no longer be seen or fixed at the final stage. So that's why the polyseal and pre-drywall inspections are the 2 inspections you most definitely want to get right. So if builders have to keep on a schedule, I get it. But if the builder only calls in for a pre-drywall inspection and does not call in a pre-insulation inspection, also known as polyseal, and maybe a low voltage contractor is yet to be there because they're behind, and with the demand that's out there, they can't keep up. So if the TV, phone, internet drops have not been drilled through the top plates and a pre-drywall is called in, the inspectors asked to try to find all these drops that aren't there. They won't see them, and then the drops get made afterwards. It's just setting the house up to fail blower door at a final inspection. So, and then the builder looks at the inspector or the energy verifier and wants an explanation of why. So that's a hard thing to swallow when you're a third-party verifier, because you're trying to explain to them what inspections are needed and when things are supposed to be there. Unfortunately, a lot of inspectors don't a lot of third-party verifiers don't notice that all penetrations have not been completed, and they do a pre-drawal inspection and move on. So we briefly went over the required inspections. So now let's get on with the show. So both the 2015 and the 2018 IECC have mandatory items that must be met regardless of the pathway being used to show compliance through the IECC. Please keep in mind that these are only the items listed as mandatory, which we'll see in the upcoming slides. They do not include other items like prescriptive, performance, or ERI items. So, and anyone looking to take the 2015 or 2018 IECC test, a large portion of the test questions are based on mandatory items and any exceptions that are listed. So the first one we've got, and this is one of the easiest one, is just the energy inspection certificate or energy certificate. Most of the time, these can be found on the electrical panel, on the outside of the electrical panel, or on the door of a water valve shutoff box located in the garage, a utility room, or in a water heater closet. So all items listed here are required to be filled out and left on site by the energy inspector. These items should be verified with what was installed and not just modeled. So meaning the inspector shouldn't take what the builder told you was going to be installed, but they should put eyes on it and verify it meets or exceeds what is listed on the permit documents that were handed into the city's plan reviewer upon request for permitting. So R402.4, so this is the air leakage for the building thermal envelope, but the building thermal envelope can consist of a single layer or multi-layer of products that complete an air barrier that will allow limited air exchange in and out of the building, such as what they call, infiltration and exfiltration. So this section, or sections 402.4.1, states that the envelope shall also comply with sections R402.2.1.1, which refers to the table with the same title, which is called the air barrier and insulation installation table. We'll see that on the next slide. And also 402.4.1.2, which is the procedures that must be followed during a blower door test, also known as what the inspector and or third-party verifier can or cannot do while running a blower door. Lastly, sealing methods between dissimilar materials shall allow for differential expansion and contractions. We've already kind of gone over that previously. So this is showing us a snippet of the table of R402.1.1. It states the components of the building thermal envelope as indicated in the table shall be installed in accordance with the manufacturer instructions and the criteria indicated in the table as applicable to the methods of construction. So we're required by the code official or a third-party verifier, all components shall be inspected and verified compliant. So this table describes kind of how each component is to be air sealed and insulated. It's kind of like a checklist that you could carry around with you if you wanted to print one out. Neither code nor manufacturers use grading language, but the installation instructions for bat insulation, as you can see at a snippet of it on the bottom, states no gaps, voids, or areas of compression. And since the classification of grade 1 states 0 to 2 by most other organizations in the maximum void gaps compressions, we're left to assume that the manufacturer and code is specifying that only a grade 1 install should be allowed. However, using performance path grade 2 with a little bit of compressions, maybe very slightly, or if not any voids or gaps, could still be shown as compliant if other testing windows, mechanicals prove to be enough energy efficiency to offset the deficiency in installation grading. So also 402.4.1.2 testing states that the building in climate zones 1 and 2 must be at or below 5 ACH, and any zones 3 through 8 must be at or below 3 ACH. When tested at a pressure differential of 50 pascals, a written report showing the results must be signed and provided to the code official, and testing shall be performed at any time after the creation of all penetrations of the building's thermal envelope. That, in my opinion, should read after all penetrations have been properly sealed, This includes electrical boxes on the ceiling, the walls, weather stripping on exterior doors, communication boxes on exterior walls and garage walls, HVAC supply boots, return boots, bath fan housings, and all low volt AV wiring openings and boxes. So a closer the house can be to being finished, the better chances are of passing a blower door test. Houses being called in for the test, but still missing trim, caulking, attic insulation, plumbing fixtures, water not being in the P-traps, or even flooring can most of the time results in a much higher testing result for blower door. The listing here also, you can see things about can or cannot be done, such as exterior walls and doors, fireplaces, stove doors shall be closed but not sealed. Dampers, including exhaust, intake, makeup air, and backdraft flue dampers, should be closed but not sealed. Interior doors, if installed, must be open. Exterior and interior terminations for continuous ventilation shall be sealed. Heating, cooling systems, if they're installed at the time of test, shall be turned off. And all supply and return registers were installed at the time of the test should be left fully open. So continue with air leakage. So R402.4.2 states that new wood burning fireplaces shall have either tight fitting flue dampers or doors. A lot of what we're seeing today is just gas logs. They have an affixed glass panel to it that does meet code, but it also should have outdoor combustion air brought in. This air must come from the outdoors. It cannot come from the attic space or a crawl space. R402.4.3 deals with the allowable fenestration leakage limits for windows, skylights, and sliding glass doors to an air infiltration rate no greater than 0.3 CFM per square feet, and the swinging doors or regular exterior doors no greater than 0.5 CFM per square feet. The label you see here on the right has air leakage section left blank, and that should be verified by the manufacturer in some means by either website or purchase order showing that it's been tested and meets or exceeds or is below the limit required by code. Again, continuing with air leakage, R402.4.4 rooms containing fuel burning appliances. This can sometimes be overlooked by the designer or builder, but rooms containing fuel burning appliances, meaning anything in climate zones 3 through 8, is extremely important to get right. When the design traps a fuel burning appliance such as a water heater or a furnace within the home's boundary or thermal boundary or air barrier, it must be thermally isolated and air sealed from the conditioned space. So combustion air and exhaust air must be brought into the space, providing the appliance with combustion air and vent the byproducts outside the envelope. With this, you should see two metal pipes in the ceiling. One is long enough to almost reach the floor of that room or the platform that a water heater is sitting on. The other will be much shorter and just barely coming through the ceiling. That's a high-low pipe that has incoming air coming in from the outside and exhaust air going, or byproducts, leaving through the one at the top. The door to that room must be weather stripped, and a threshold at the bottom of that seal door must be closed. So a lot of this stuff seems self-explanatory, but trust me, it does happen in the field, and it has happened to me from a large volume builder that no one caught it on design and no one caught it on permit documents. And this is a very health and safety issue, it was poorly designed really, but it could be mitigated if it was excluded from the conditioned space. So it's a health and safety thing that the energy code kind of blends into with other health and safety issues. Also, R402.4.5 recessed lighting. So states that all recessed lighting must limit air exchanges into the envelope. These must be an IC rated, meaning they can be in direct contact with insulation like you see in the photo. Insulation can be put all over the top. And they must be labeled have been tested with an air leakage rate of 2.0 CFM or less. Most of the time, labels are placed inside the can. Usually it's a bright orange or a bright yellow sticker. The air tightness is usually listed on another label, either on the inside or the outside of the can. It looks like little specifications from the manufacturer. A rule of thumb is if a can does not have air vents on the top of it, then most likely it's meeting the requirements of ICAT, insulation contact, and airtight. But if not, it may also be necessary to look up the information on the manufacturer's website. Most of what's being sold today at supply houses for builders, they're getting away from anything that's vented, and you won't see that being installed. So R402.5 maximum fenestration for U factors and SHGC for windows and skylights. So U factors and SHGC values are verified by using manufacturer's provided label, as what we see here. These should be affixed to all windows and skylights, but due to product shortages, it's not always been the case. Say some windows are being installed without verification of its insulation properties. With a volume builder, it's not likely they went outside of their normal vendor and purchased the wrong window. But if it's a custom builder and the homeowner has a hard deadline to move in, then to keep on schedule, the builder or purchaser might just buy anything they can get delivered on time. This can sometimes be a very bad decision because if the insulation, the U value and SHGC properties are not verified to be acceptable for that climate zone in which the house is being built, that might have just become the house may have just become a greenhouse. So northern windows do a great job of keeping heat in a home. Southern windows do a great job of keeping heat out of the home. The label you see here has a map at the top. These are northern style windows, but the map shows that anything in the blue areas are certified for those areas. A southern label would have just the opposite blue or just a gray shaded. Not all labels include these helpful maps. Systems and specifically controls at R403.1, each HVAC system must have its own thermostat. Running more than one HVAC unit on a single controller is no longer allowed. Builders sometimes offer game rooms, bonus rooms, media rooms, additional bedrooms, and sometimes they just add that single extra bedroom or game room on top of a normally built single story. And if an additional HVAC unit is needed to cover the heating and cooling loads of those additions, it must be controlled by its own thermostat. It cannot be controlled by the main unit on the main floor. Of course, the exception is the zoning system. So if they have one system, two stats, that's acceptable, but not having two stats and two systems and one thermostat, that's not acceptable anymore. 403.1.1 programmable thermostats. So this is something I see a lot. So allowing contractors, if we read what it says here, it says it must be programmed, and it must have setbacks, and it must not have a temperature lower than or greater than. But we see this a lot of the times where contractors are allowed to turn the AC units down into the 60s or less during the summer and into the 80s or higher in the winter. I know installing floor in the house needs to be warmed for installation, but most of the time it's just left at the higher setting. So even though this does not affect the homeowner or energy bill of an occupant, this is a huge waste of energy and that's being consumed during construction. So a lot of times the AC is running while the windows and doors are left open. This too wastes a huge amount of energy. The stats should be programmed with a basic setback that adjusts the homes during the nighttime hours to lessen overall energy consumption. So I've yet to really see that happen. So if it's just set with the basics, anything after 7 or 8 o'clock at night, it goes up or down depending on the season. And then it comes back on at, let's say, 6 o'clock when the workers or contractors or trades start to occupy the home. So before the homeowner moves in, all stats should be set to a minimum or maximum of not more than 70 for heating and not lower than 78 for cooling. But the stat you see on the right is one that's no longer allowed by code because it cannot be programmed. So 403.1.2 heat pump supplementary heat, also called emergency heat or supplemental heat. Heat pumps are great pieces of machinery because they move heat instead of creating heat. There's no byproduct losses, means these are highly energy efficient compared to gas furnaces. Their only downfall is during their defrost cycle or when the outside temperature is too cold. So in most cases, the electrical resistance heat will have to come on and waste huge amounts of energy if the compressor alone cannot meet the load when running in the heat mode. So we saw this a lot in Texas during Ice Storm Uri. Today's heat pumps can supply heat even down to temperatures close to freezing, or even sometimes a little lower than that. And the stat in the unit should be programmed and set by the installer to not allow the heat strips to come on unless the compressor cannot meet the load. So during Uri, most heat pumps had to use the electric resistance heat, and put a large strain on an already struggling electricity or electrical grid. On to the next thing, ducts. So R403.3.2, duct sealing. So all ducts, seams, air handlers, filter box, plenums must be sealed, and joints and seams must comply with either the IMC or the IRC on proper sealing. So the IECC does not specifically specify how it needs to be sealed. It just says it has to be sealed. It doesn't really tell you the material that needs to be used, the thickness, the zip ties, the panduits, however it needs to be done. You'll have to look in the IMC or the IRC to see full compliance with how that needs to be done. As you notice, we're not really talking about duct insulation. That's because it's not a mandatory item. It's a prescriptive item. But try getting a software like IC3 or ResCheck to show passing compliance reports without duct insulation. It doesn't happen in our climate zones. So that's something that needs to be done. It does specify in prescriptive the sizing that it needs to be for duct sizing. If it's over a certain size, we'll not go into that because it's prescriptive only. 403.3.2.1, sealing of the air handlers. So all seams between furnace and air handler, plenums, filter boxes, coils must be sealed, and furnaces and air handlers must be tested to be shown that the cabinet leaks no more than 2% of the designed airflow. So for example, if a furnace or an air handler is a 3-ton, it gives us an airflow of 1200 CFM, which is 400 CFM per ton times 3. So that allowable leakage just by the cabinet, by the manufacturer, is allowed to leak 42 CFM. A common duct testing target on a 3-ton system would be in the neighborhood of somewhere like 46 CFM, depending on the square foot of the house. So out of that 46, if 24 of that is allowed by code for cabinet leakage, that only leaves 22 CFM to leak for the entire duct system. So that's why it's very important that duct systems be mastic, panduit, strapped, and sealed to the best ability of the contractor. So any of us that's done duct testing can attest that basically a 22 is a very difficult target. Even 46 can be difficult at times, but it can and has happened. But for this to be consistent, that's asking a lot from the contractor. So sealing the cabinet and not having undue leakage, like the picture you see at the bottom, it basically shows a picture of a heat pump being very well sealed at the transition between the air handler and the supply plenum, but the contractor failed to mastic around the line set pipes, the condensation piping coming from the cabinet. So even though these have rubber grommets that come from the manufacturer, these are easy areas that can be additionally sealed to lower cabinet leakage and allow for more leakage to happen in the duct test, in the duct system. So that is easier for the contractors to get a passing score on a duct test. So speaking of duct testing, again, R403.3.3 mandates each duct system must be tested, but it only states that it must be tested. It does not have a target or a limit. So it states that the testing be performed at a pressure difference of 25 pascals and can be performed during a rough-in inspection or a final inspection. The actual testing targets come from a prescriptive measure, but when you put in for an energy model, IC3, ResCheck, it all asks for duct scores, and that basically is giving you a target that you must hit to be compliant. During testing, all supply and return boots at a final should be covered or taped. If the fresh air, also known as mechanical ventilation, is tied into the duct system, or it dumps into a plenum, then the inlet or outlet cannot be taped. It must have a damper that closes during the testing. So that last one I deciphered from a few places in the code. R403.6 states that the mechanical ventilation must have an automatic or gravity damper, but nothing is mentioned in the testing procedures of duct testing on how it's to be sealed. However, the blower door testing procedure states that the inlet or outlet can be sealed during the testing if it's continuous. So you kind of interpret that into saying one way or the other, it needs to have a damper that closes when not in use. In my opinion, with a much smaller volume of air being tested during duct testing compared to a whole house target like a blower door, and the volume of air used in a blower door, the duct system should be tested as it would be in normal operations and not allowed to give a false test result by allowing a portion of the system to be taped, which would otherwise not be during normal operations. Lastly, a written report of the testing results must be signed and provided to the code official. R403.3.3, again, continuing duct testing. In 2015, 2018, there is an exemption for not having to perform duct testing. That's not the case in 2021. 2015, 2018 says if the home is fully encapsulated and all ducts and air handlers are 100% inside the thermal envelope, testing is exempt. According to that logic by code, if even 1 foot of ductwork or equipment is outside the envelope, the system must be tested. It does not give an allowance for partially encapsulated systems. The second exception is for mechanical ventilation, which includes ERVs, HRVs, inline and standalone fans that does not dump into a plenum or ceiling return. Those are exempt from also being tested. Each of these you see pictured here in this slide basically are tied into the system and must not be taped and have a gravity damper that is closed during testing. 403.3.5, building cavities. These include wall cavities, floor cavities, including floor cavities over conditioned space, return boxes like you see here. I've seen these plenum platforms, these return platforms, these return boxes being passed every day, and no one makes a comment about these not meeting code. In order to be compliant, they really should be lined with ductboard, including the bottom of the floor. All joints and seams be sealed with UL 181 tape or mastic. These are huge sources of leakage at the time of testing, but even if they get sealed and passed during construction, it will not last for long. The seams and joints will crack and more leakage will occur. This is most likely due to the difference in expansion rates between the wood to wood connection and wood to concrete connection, allowing for leakage. Also, when's the last time you saw these cavities being cleaned out or vacuumed out before the unit is turned on? Usually there's empty cups, leftover lunch, empty tape rolls, and all other kinds of trash that's being left in there. If they're having to put ductboard and sealing all the seams, they'll be cleaning those out and installing the proper ductboard to make that work. R403.4, mechanical system piping installation. These include, but not limited to, hot water piping, the large refrigerant line for HVAC units, and the condensation piping from the main condensate line for the HVAC unit. So a lot of times the condensation pipe is overlooked. So any joints and connections within this insulation should be taped to avoid any future separation. R403.5.1, circulation system. These are not usually found in production homes, but you see them on larger custom homes. Different configurations are allowed, but gravity and thermosiphon systems are not. They must have controls that can turn off the pump when the water temperature is satisfied or there's no longer a need for hot water. Heated water circulation and temperature mechanical systems. Again, these are not really something we normally see. Specifically, the heat trace systems, not found really in production homes, but when they are, other technical standards will have to be referenced in order to verify compliance. R403.6, mechanical ventilation systems, they also known as fresh air. The big question always comes up for me, do houses need to breathe? The answer to that is yes, and we want to control when and how much, not uncontrollably. As homes are built tighter and tighter, the chances of having good indoor air quality starts to quickly diminish. In order to keep the bad at acceptable levels, the indoor air must be either exhausted to the outside or diluted with incoming air from the outside. There are a variety of mechanical ventilation systems, also known as fresh air systems, ranging from tie-in systems that use the air handler as the fan system to standalone systems that use far less energy for the same amount of air. Due to the increased energy use, using the air handler as the fan usually fails energy modeling and must require a standalone fan to be used due to the fact that the air handler uses such a high watt draw and energy usage. It is not allowed in the energy model and must resort to a smaller fan unit. With the 2015 and 2018 IECC, it was only required to have mechanical ventilation, but it is not yet required to be tested. It only has to be verified that it's correctly installed and that it works, meaning that the verifier has to make sure that the damper functions by opening and closing when the fresh air is being called for, and then closes when it's not being called for and not in use. With the 2021 IECC, testing will be required, and the ventilation rate will be based off of an ASHRAE calculation based on square footage of the home and number of occupants. So 403.6 mechanical ventilation continued. So in order to meet the increased energy efficient levels of 2018 IECC, the compliance through energy modeling, we just kind of talked about that, but fan watt draw. So basically a standard air handler would draw anywhere from a 400 to 700 watt draw compared to 17 to 25 on a smaller standalone fan. That's why most of the time those are needed over the air handler being used. Volume builders know this. Most of them model it and design it that way. But I ran into a lot of one-off custom builders, smaller builders. They have no idea. The HVAC guy has no idea. The only way they find out is during the final inspection when someone says, where is your fresh air or mechanical ventilation? Now at this stage, the cost of installing it is higher. Sheetrock, brick, stone have to be removed, and electricity has to be ran to the box. So any plan reviewers out there should look for this, mark it down for correction before plans are approved. That way that those things are being done in the planning stage and framing stage and not having to be done later. If the HVAC contractor isn't aware of the requirements, suggest that they consult a third-party energy verifier who can walk them through the process. With this exception that's listed, any and all blower motors that are on the market today are ECM controlled, which means they can ramp up or down when the fan speed it needs to be faster or slower. This does make them more energy efficient. However, a bit of caution again on this. Using the performance path, which most builders do, it is not easy to get an energy model to pass, even when using an ECM motor. In the 2021 code, it even makes it harder, and that did start with 2018. Less and less homes will pass energy modeling per the 2018 and 2021 and beyond by using the air handler. That is usually not something that you want to do. R403.7 equipment sizing and efficiency. So in 2015, 2018, using the manual S and manual J is mandatory, but it is not mandatory to turn these in or have third-party verifier review them. However, if the code official or third-party verifier requests these, it must be shown that they were used to design the system. Manual J is used to calculate heating and cooling loads inside the house, means the software uses all the available data, such as wall and ceiling insulation, window value, SHGC orientation, climate zone, design parameters, infiltration, exfiltration to calculate how much in BTUs it will take to condition the home in both heating and cooling. That BTU information is now fed into the manual S. The manual S is used to size the correct equipment where the output matches or exceeds the amount of BTU loads needed that were previously calculated. Please do not only allow the AHRI to verify correct sizing. I've seen that a lot with builders. They turn in an AHRI certificate hoping to pass that. So if a few cities in Texas have already been requiring documents to be submitted with permit requests, the manual J, manual S. If your city is not currently doing so, you should seriously consider it. So this is not only assures the correct size of the equipment is being used, but it also almost guarantees the homeowner will be more comfortable and less energy is used to condition the homes. 403.8, system serving multiple dwellings. We don't normally see this, but in cases where multiple dwelling units are being served by one system, commercial sections must be followed. C403 is the building mechanical systems, and C404 is the service water heating sections. Normally with these type of buildings, you see them in low-rise apartments and or third story or less university dorms. So 403.9, snow and melt ice controls. We don't normally see these in Texas, but sometimes in Oklahoma and in the hill country around Austin, maybe. These are not only used in flat work such as walkways and driveways, but can also include roofing systems that prevent damming that can lead to serious problems within the structure. So these systems must have automatic controls that are capable of shutting off the system when the pavement temperature is greater than 50 and precipitation is not falling, like in flat work, driveways, walkways. They must have also an automatic or manual control that allow for a shutoff when the outdoor temperature is greater than 40, like when using on roofing. Pools and permanent spa. So basically the energy consumption for pools and permanent spas have to be in accordance to sections 403.10.1 through 403.10.3, which we'll go through right now. Point 1 is the heaters. Basically, the electrical power to the heaters shall be controlled by a readily accessible on-off switch that is an integral part of the heater, and it also should be mounted on the exterior of the heater or external somewhere within 3 feet of the heater. Operation of those switches shall not change the setting of the thermostat. Such switches also it's an addition to the circuit breaker from the power to the heater from the house. Gas-fired heaters should not be allowed to have continuously burning ignition pilot systems. Continuing with that as well, 10.2 is time switches. Time switches of either control methods can be automatically turning off and on according to preset schedule and should be installed for heaters and pump motors. Pump and heater motors have built-in time switches, which will show as compliant. You see to the right, there's digital and there's mechanical. An exception to that is if it's used for public standards, if it's required to have a 24-hour pump operation and or pumps that operate solar and waste heat recovery pool systems. So it is more times we see solar being used for things other than the main house. That second exception may have to have a little more investigation to see how much solar is being used in order to show compliance. Any heated pools must have a cover installed that has a vapor retardant and that keeps the conditioned heated water from evaporating and wasting the energy used in the pool. However, if more than 75% of the energy used to heat the pool is generated by on-site renewable energy, such as solar, either by electrical panels or hydro panels, then a cover is not required. Portable spas such as the one you see here must be controlled by the requirements of an APSP-14, which is the Swim, Spa, and Hot Tub Industries Energy Efficiency Standard. So that references a different standard. Lighting equipment. So in the 2015, the percentage for high efficacy lighting was 75. With the 2018, it's 90. For the 2021, it will be 100%. High efficacy is calculated by dividing the lumens, which is the amount of light generated by the bulb or the fixture, by the number of watts of energy used to generate that amount of light. For example, a 60-watt incandescent bulb that gives off 2,500 lumens produces 42 lumens per watt, and in the same kind of LED giving off the same light but only using 14 watts produces well over 178 lumens per watt of power for the same amount of light being generated. So high efficacy bulbs include most CFLs and then just about all LEDs that we see being installed in houses today. So that's it for the mandatories. If you've got any questions, let me check the chat real quick. I see there is one question here. Just want to let you know that the next webinar will be December 2nd at 11 a.m. titled 2021 IECC and what happened to the mandatory requirements. We're going to kind of do the same thing as we did before. Okay, it's not really a question. We're kind of do the same thing as we did just now, but it's going to be basically mostly over the 2021 and how to read through that for prescriptive and performance measures to be to show compliance. So if anybody has any questions, now the time, just put it in the chat. We'll go through that. Let me see. Yes, the recordings will be made available. They will be loaded up on our SPEER's YouTube channel. It will be, there's a resource page on our website. If you go to the resources page, the very first link there says YouTube channel. You can click on it, and usually it's listed by the latest ones first, and you'll see these pop up in that, and the latest ones going that way. But be sure and check out the rest that are there. There's policy, there's legislation, there's a couple of interviews we did with some people that are historically been done before I got here. But we're going to continue these webinar series every other week and go through that. There's another question that came up here. Should attic HVAC equipment be taped or mastic? I could not find code requiring both. That's a great question. It basically, code does say in an approved method. And when it says approved method, it needs to be approved by UL 181, which, yes, tape is silver tape that has a stamp or logo that says UL 181 approved, is approved as sealing methods. Most of the time that isn't used only tape because of the fact that it allows for leakage, but I do see a lot taping to hold it together and then masticing over that. Taping up the seams on HVAC equipment is usually easier to seal by using tape, but trying to use tape to mastic connections for ductwork doesn't normally happen very well, and it's very problematic and allows for a lot of air leakage in the attic and failing duct tests. So any more questions here? I'll allow this just a couple more minutes to keep running if there's any more questions. Thanks again for answering in the surveys or poll questions in the beginning. That'll help me focus my trainings going forward. I know we have a lot that participate from the South. Jason primarily was in the South. I'm more remotely in Dallas North. I hope to get out and see most everyone that have participated with us throughout Texas and Oklahoma. But Texas is a large state. That's why SPEER only covers 2 states. Instead of 5, 6, 7 like other RIOs like ourselves. So if there's not any more questions, I'll end it here. Again, screenshot this, take a snapshot on your phone if you want to contact me via email or phone call, and I can help you with any questions that we got. One last little tidbit of information, what's coming up a lot, and I say a lot, is the SEER 2 questions that are coming up for the January 1, 2023 deadline. We're having to field those questions for commercial on the equipment. It's a lot of panic that's happening from the EPA making an abrupt about face on this new requirement. So if you have anyone that has questions that need further explanation, by no means, please just send them my way and we'll help them answer that question as best that we can. So if there's no more questions, I appreciate your time. Thank you very much and look forward to seeing you guys on the future ones. And then don't forget to fill out that course evaluation you get from Kathy. Usually it's between 48 to 72 hours. Thanks again and have a great holiday. I appreciate it. One last question popped up. Are the CEUs available for this session? Yes. The evaluation form will be sent to you via email from Kathy Lawrence. Once you submit that, and then you'll get a course completion certificate from Kathy Lawrence via email. It will include the course ID number on it that you use to turn into IECC for your CEUs. So I appreciate it. Thanks again.